Hello viewers, welcome to Joseph-Oroks science class. Today we shall be talking about free fall, or you can term it motion under gravity. Now let's assume a boy releases an object from a known height h. You see, the boy is standing right here, releases a ball from this height. Now this object or this ball will fall freely under the influence of gravity G. That is to say, the object will experience a downward acceleration of 9.8 meter per second squared. When this happens, we say that the object is in a state of free fall. Now, the motion of this moving object falling freely from a known height can be described using the familiar equations of motion, which we already know. H equal to ut plus minus half gt squared, v squared equal u squared plus minus 2gh, v equals u plus minus gt, and lastly h is equal to the average of the velocities times time. Now, we are going to use these four equations of motion to describe the motion of this moving object falling freely from a known height. Now, before we delve properly into that, I would like to intimate you with some conceptual characteristics of a free fall motion, or you can call them principles of a free fall motion. Now, what is the first conceptual characteristics here is that if an object like this object is dropped freely from an elevated height, this object will experience a positive acceleration. Now, why is it so? It's because this object is falling from this height, is falling in the same direction of gravity, so we label this G to be positive. That is concept one. Then the second concept is that if an object is thrown upward, take for example, if I have a boy standing right here and this boy throws an object, or let's say a ball, upward, it travels up. Now, as this object is thrown up, this object will experience a negative acceleration. So in that case, we say G is negative. Now, the reason why it is negative because it is opposing gravity. Gravity always acts downwards, so anything acting upward is always opposing gravity, or you can say it's against gravity. So that's why G here is minus 9.8 meter per second squared. Now, that is number two. The third concept is that if an object is dropped from a height, like this case, wherein we have this ball being released from this height h, then the initial velocity of this object or this ball will be 0. At this point, the initial velocity is what? Is 0. This object has a final velocity. So as we proceed in this lecture, I will show to you how we can calculate the final velocity at which this ball is moving. Now, the fourth concept is that if an object is thrown upward, that is, for this case, you can see here that this object or this ball is thrown upward in a perfect vertical direction. Upward, you can see it. Now, at this point here, that's at maximum here, our velocity is what? Is 0 meter per second. Now, you may want to ask, why is the final velocity is 0? The reason is that gravity slows down the object during its upward motion. You see, when you throw an object up, this object is going against gravity. So the further it goes, as it's traveling upward, it becomes slow. The object rises upward, it begins to slow down. Now it gets to its peak of trajectory, and at that point it becomes 0 before returning to the ground. Now the final salient point here is that if an object is projected upward, the velocity at which it is launched upward is equal in magnitude but opposite in direction in sign to the velocity that it has when it returns to the same height. What that means is that, let's assume I launch an object up, let's say with a velocity of 30 meters per second. Let's say as this ball is going upward here, it's launched upward with a velocity of 30 meters per second. Now this ball will go up and return back with the same velocity, 30 meters per second. This is the same magnitude, but the direction will be what? Will be in opposite direction. So that's what this negative is here. So these are 4 principles that are very, very important in describing motion of an object falling freely from a height. Now, we can combine these 4 principles with the equations of motion to solve problems involving motion of free falling objects. Now, for us to do that, we are going to consider about 5 cases. 5 cases in the sense, we're going to have case 1. The case 1 is termed free falling object dropped from a known height. Free falling object dropped from a known height. Case 2, we're going to consider the motion of an object projected vertically upward. Case 3, we shall look at motion of an object projected horizontally from a height. Then case 4, we're going to look at the motion of an object projected at an angle to the ground. Then case 5, we shall take a look at object projected at an angle theta from a height. Now, in this video, I'm going to talk about case 1. Free falling object dropped from a known height. Now, this diagram I have here, I'm going to use this to describe the motion of this free falling object from this known height h. Now, what are we going to look at? We're going to see how we can calculate for the velocity with which this object is falling. Then we're going to find the height, the distance from the point where the ball or the object was dropped to the ground, the distance between these 2 points. We're going to look for how we can calculate that, and also we're going to find the time it takes for this ball to travel from this position here to the ground. Now, the first one, how can we calculate for the final velocity? Because we already see that the initial velocity here is what? Is 0. For us to calculate for the final velocity, we're going to make use of this equation 2 and equation 3 here to find our v. Now, let's quickly see how we can do that. From this equation 2, we already know that v squared is equals to u squared plus 2gh. Now, if you check this equation here, we can see that we are having double signs here, positive and negative. I've explained that already, that g can be positive and g can also be what? Can be negative. it is positive because it is dropped from a height downward. It's in the same direction of gravity. But if it's in opposite direction of gravity, then we say here, we take here to be what? To be negative. So for this case one, we can see that the ball is dropped from a height here to the ground. So it's in favor of gravity. So that's why I'm having a positive sign here. Now, u is equals to 0. From this diagram, we can see that u here is 0. So if u is 0 here, we can see that v squared is equals to 2h. So we can make v the square root of formula to give us 2gh. So this is one way of finding the final velocity of this object falling freely from a height. That is to say, this equation will be very handy when the height is known. So we can calculate for v, and g we know is always constant. Then also we can also find v using the third equation. And for us to do that, we're going to write it, we're going to have something like this: v equals to u plus gt. Now we already know that u is 0, so this implies that v is equals to gt. Now this equation will be handy if the velocity, if the time taken to fall this distance is known. So we can see here that these two equations, we can use it to find our final velocity depending on the parameters we are given in our question. Then also, let us see how we can calculate the height. That's the distance from where the ball was dropped, the distance between the position where the ball was dropped and the ground, which is our h. Now for us to find h, we can find h using equation 1 and equation 2. Now from here, let us find h. In finding h, we see here that h is equals to ut plus half gt squared. Now u is 0 here, so our h will be half gt squared. So with this we can calculate the distance, that's the height, if t is given. Now on the other hand, we can use equation 2, which is v squared equal to u squared plus 2gh. Now here u is 0, so my v squared here is now 2gh. So we can make h our subject of formula to have that h is equals to v squared all over 2g. So this equation will be very useful if the final velocity is given. We can calculate height using this. Then if the time is given and the final velocity is not given, and the question is prompting us to find height, then this equation will be very, very handy. Now lastly, I want to show to you how we can calculate the time it takes to fall this distance. That is to say, the time it takes for this object to fall from this height here to the ground. Now how can we deduce that? We can deduce that using our first equation, which is h equals to ut plus half gt squared. Now from this formula here, which we have derived, we can make t the square root of formula here. Now in doing so, we're going to have something like this, that is h is equals to half gt squared. Now making t the square root of formula, we're going to have that making t the square root of formula by taking square root of both sides, we're going to have that t is equals to 2h all over g. So this is the time it takes for the object to fall at distance h. Thank you very much for watching my video. So please don't forget to subscribe to my channel. Now in our next video, we are going to talk about motion of an object projected vertically upward, which is our case 2. Thank you. See you next time.